Welcome to our Virtualized Networks module. Software-Defined Networking, or SDN, is a new technology that allows you to design virtual local area networks. You can use virtual switches, which have usually been available in your hypervisors for your virtual machines, but are now available to connect between hypervisors. Software-defined networking is programmable. You have control of the network across a cluster, and you can program it within the hypervisor. It is flexible and elastic because you can dynamically adjust your traffic flow to meet your needs. It's centrally managed in a software-based SDN controller. Here, the administrator is provided with a graphical, global view of the network, which appears to applications and policy engines as a single logical switch. It's extensible and you can gain interoperability through new protocols. And it's dynamic because you can configure, secure, manage, and optimize your resources very quickly through an automated dynamic SDN controller. Since software-defined networking is a newer technology, you should make sure that you understand the risks of it before you implement it in your organization. How can you effectively monitor the traffic on the network when the entire network is virtual? How will you handle the confidentiality, integrity, and availability of your network? These are all questions that need to be addressed before you implement software-defined networking in your enterprise. Software-defined networking is programmable and works well with your virtual machines. It provides for the physical decoupling or separation of the network control plane of packets from the data plane or your hardware, which allows you to have high bandwidth and processing power that is available on demand. It separates your network into an application layer where your applications will run, uses APIs to interface with the control layer where you have your software-defined networking control software and your network services. And then you have a control data plane interface which communicates with the infrastructure layer where you have your actual physical network devices. You can also virtualize network storage with software-defined storage. SDS allows you to create a scalable storage architecture that can be installed on your existing resources or off-the-shelf hardware. You can integrate old, new, and proprietary solutions and pool your resources so that they can be centrally managed. You can dynamically manage the path data takes in order to increase performance, and it allows you to better use your storage capacity to protect your investments. There are protection and data availability mechanisms built into SDS, including intelligent data placement, supported by caching to increase speeds, software controllers which can work across platforms, and software RAID with intelligent mirroring to make sure that your data is not lost in case of a hardware failure. You can also virtually segment your networks with private VLANs. Private VLANs can extend the capabilities of traditional VLANs or virtual local area networks. It allows further segmentation of your local broadcast domain to create private groups. Port isolation allows you to isolate a single port on one VLAN and use this for management. This prevents unauthorized systems from attempting to modify your network settings. Your primary private virtual LAN is the original VLAN, which is then divided into smaller groups. Secondary private VLANs exist only inside the primary VLAN. They have specific VLAN identifiers, and the physical switch associates the behavior with the VLAN ID in each packet. You should remember for the CISSP examination that port isolation is important to segregate your management systems to prevent unauthorized individuals from accessing and modifying your network settings. This concludes our Virtualized Networks module. Thank you for watching.